This is a short video that's going to prove the sine rule. I'm starting with the standard triangle ABC, ABC with capital letters for the angles and ABC with small letters for the sides. And as usual, the corresponding pairs are opposite each other. So angle A is opposite side A, B opposite B, and C opposite C. This proof is just going to concern itself for the moment with A and B, so angle A and side A and angle B and side B. And I've arranged it so that the triangle is flat along the ground. So it's just any triangle whatsoever. It doesn't have to be right angled. It could be, but it's meant to represent the general triangle, and I've put it flat along the ground. And then from the top here, I'm going to drop a vertical line. So the vertical line and the horizontal line obviously meet each other at 90 degrees. They're perpendicular to each other. I've labeled the vertical line as H for height, not H for hypotenuse, but H for height, and it's formed two right-angled triangles. Now in the first right-angled triangle on the left there, I've got H and B. H is the height, it's opposite the angle A, and B is the hypotenuse of the triangle, it's the longest side. So by definition, H over B equals sine A. That's just what the definition of sine is. Multiplying both sides of that by B, I get that H equals B times sine A. So the height of this triangle is B times sine A. Now I'm going to look at the other triangle, and I've got angle B in this one, and side A is the hypotenuse of this triangle, and side H, not the hypotenuse, H isn't standing for hypotenuse, but H is the opposite angle to B there. So because we've got the opposite and the hypotenuse, we can say that H over A equals sine B. That's just the definition of sine, opposite over hypotenuse. So since H over A is sine B, if I multiplied both sides of that by A, I'd get H equals A sine B. So I've worked out the height of the triangle in two different ways. From a right-angled triangle on the left, I got H, the height, is B sine A. But then from another right-angled triangle on the right, I got H, the height, equals A sine B. So therefore, those things are equal to each other. B sine A is equal to A sine B. And dividing both sides of that by sine B, I get B sine A divided by sine B equals A on its own. And then dividing both sides of that by sine A, I get B over sine B equals A over sine A. And I could have done that for any pair of sides and angles in the triangle, so I chose to do it for the A's and the B's. I could have done it for the A's and the C's, or the B's and the C's. So that gives us the sine rule that A over sine A equals B over sine B equals C over sine C. So that's the sine rule. A over sine A equals B over sine B equals C over sine C, where the small a's, b's and c's are the sides, and the big a's, b's and c's are the angles, and the corresponding pairs are opposite to each other, A opposite A, B opposite B, C opposite C.